G'day all, in this video we're going to be proving that each pair of triangles are similar, and these kinds of questions where the triangles are sort of in each other, okay, and they're made up of each other. So with our first one, all it is just make sure that you are looking out for your similar angles and sides and those types of things. So we're going to break down this first one, okay? So first first off, hopefully we can see that two triangles, we've got two triangles here. We've got triangle ACE and we have triangle BCD. Okay, so there are our two triangles here. So first, hopefully you do notice that this here is common in both. Okay, so that's our first sort of similarity that we can write down. So we can say angle ACE is equal to angle BCD, and we can just say that this is common to prove it. Alright, so next we can look at what other information we've got. You will notice we've got these arrows on the line. These arrows means that they are parallel. So this tells us a bit of information and how can we find angles from parallel lines. So we need to look at these interior angles. So make sure you are looking at the interior angles. We've got this one here. Okay, it looks very much like a right angle though. And you will notice, because these are parallel lines, this angle here, we call these corresponding angles in parallel lines because they're on the same spot, but they're on the other parallel line that's going through, with our transversal line going through, which is that line down the bottom. And also, if you look at our longer line up the top here, so this line that goes all the way up here, we've got an angle inside here of our parallel line and an angle there. You'll know, because it's the same line going through, these angles are also going to be corresponding. So we've got two lots of angles here that are corresponding. So we're just going to write that out here. So we've got angle, and it's going to be CAE is going to equal angle CBD. Make sure you get it right. And I'm just going to put the other one right next to it because they're both corresponding angles. And we've got angle CEA is going to equal angle CDB. Okay? And we can say this because they're both corresponding angles in parallel lines. Alright. So now we just need to put our similarity statement. So with this, therefore, triangle ACE is going to be similar to triangle BCD. And this is because of the angle similarity. Okay? So this is question A fully answered. Okay? Always finish on your similarity statement that I've just done there. So make sure you don't forget that. Okay? Now B. We're going to be looking at two triangles here. First, we've got triangle ABE. And we've got triangle ADC. Okay. So just note, this one is a little bit different from our last question. Okay. You will see that the lines or angles aren't going to be corresponding in the same sort of place because we don't have these parallel lines here. Alright, and you'll notice that this triangle here isn't just an enlarged version of the smaller one. Okay, it's been enlarged and also transformed in a way. Okay, so you can take note that these, I'll just get rid of these. So you can just take note that these lines here, they're not at the same angle. Okay, so it's been enlarged, but it's also been rotated in some point. Okay, or reflected. So it's had other transformations happen to it. But we can still work this one out. So first, let's break down what we know. Okay? So out of both of our triangles here, ABE and ADC, they share the common angle of A. So we can write that down. So angle AC, sorry, don't want to start off with A. I want that in the middle because it is angle A. So CAD of our bigger triangle is going to equal angle BAE of our smaller one. And this is because they're common. So we have that there. Now with this question, we need to work out scale factors. But first we need to figure out the sides which correspond to each other. So the sides that are similar to each other. So, as I said, you can always go from your longest to your shortest. Okay, so our bigger triangle, this one here is our longest side, the 9. Alright, and then our longest one for the smaller one is this 3 here. Okay, then we have our second longest, which is this 7.5, this bigger one. And our second longest of this one is 2.5. So this is how you can sort of break down which side does belong to which, okay, if they are similar. Alright, so now we just need to work out our scale factor. So just remember, scale factor is equal to the image over the original. Sorry, I'm being lazy and not writing it all out, but hopefully you heard that. So with our first one, if we're looking at AD, so the scale factor here is going to equal AD, and the corresponding side from A to D is A and B. So this is in the green there that I've highlighted. Okay, or BA, doesn't matter which way you write it. Okay, so this here is going to be 9 over 3. 9 divided by 3 is 3. Alright, now we need to check another scale factor. Okay, so we need to do a different one this time and see if it also equals 3. So we're going to look at our second longest sides, 7.5 and 2. Make sure you write them in the same order. So we did our big triangle first, so this is AC, and this is going to be over AE of our smaller triangle. So this becomes 7.5 divided by 2.5. So this also equals 3. So we've got two sides that are the same scale factor, and we have one angle that's the same. So we can write our similarity statement. So therefore, and always finish on this, triangle ACD or ADC is going to be similar to triangle ABE or AEB. I'll put the letters in the right way just so it matches each other up. Okay, and this is because of SAS. Okay, so hopefully this helps with breaking down on how you can prove that triangles are similar. There's a couple of different ways. Remember, there are different ways to prove that things are similar. So you could have side, 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 where you're just comparing the scale factors of all the sides. You could have the right angle hypotenuse side theorem as well. Alright, so just make sure that you are using an appropriate theory for proving that they are similar. Okay, so good luck with trying to work out your proofs, and hopefully this has helped greatly.